Alright, so let's start our next part of our lesson by examining a shunt series type of feedback. And a shunt series feedback, we'll find in a moment, makes a good current amplifier. Alright, so in our shunt series amplifier, what we're going to do is we're going to ground the first transistor's emitter. We're going to go through a feedback resistor RB and another feedback resistor RF to connect back to the input. Alright, so here at the output, if we were looking for our voltage signal, it would have to go through both the transistor and the feedback network to get to ground, so it's definitely a series feedback at the output. Now remember, our signal is likely going to be an output current in this case. We're going to feed back some of this current to the input. So we have our input current coming in here, IN, our error current going into the amplifier, and our feedback current, I beta, coming into the junction of those nodes. Now what we know here is that this would be a shunt feedback. We have some kind of current summation, so we have a shunt circuit at the input. We also note that shunt connections reduce impedance, and series connections increase impedance. And so what we've done is reduced our input impedance and increased our output impedance. And if you remember, for a current amplifier, those are the exact conditions that we would like to see. Alright, so let's look at one more example here, or two more examples I should say. We'll look at a series feedback and a shunt feedback. So a transistor level example of a series feedback might be a network that looks as follows. We use a pi resistive feedback network. That looks something like this. And in this case, we see that our output voltage would have to go through both the amplifier and the feedback network, and our input voltage would also have to go through the amplifier and the feedback network to get to ground. So this is definitely a series connection, and we use the series to increase the input impedance. In other words, we'd like a voltage input, and to increase the output impedance, we'd like a current output. So voltage input current output, or a transconductance amplifier. Alright, so let's look at a shunt amplifier here. So here our input signal is referenced to ground and our output signal is referenced to ground. We can go through either the feedback network or the amplifier to get to ground at both the input and the output, so we have a shunt amplifier. Now, in the shunt amplifier, we reduce the input impedance and we reduce the output impedance. So, for reduced input impedance, we'd actually like to see a current at the input. And for reduced output impedance, we'd like to see a voltage at the output. And that makes the shunt type of feedback network good for a transresistance amplifier. Alright, so in the next lecture what we'll start doing is looking at the mathematics behind how this feedback works.